Welcome to Scaling DevSecOps with GitHub and Azure. I'm Stephen Murawski, a principal cloud advocate at Microsoft, and I'm joined today by Lavanya Kasarabada, Senior Program Manager on the Azure Security team. As we go through the session, we have subject matter experts in the chat waiting to answer your questions. And while we definitely can't touch on the whole DevSecOps landscape over the next half hour, our subject matter experts will do their best to help you with any of your questions. Now, today, we're going to set the stage for you for why DevSecOps matters, highlighting some of the challenges that we face. We'll explore DevSecOps best practices and look at some of the tools and services that Microsoft offers to help us apply those practices. This being the Build Conference, we have to apply those principles to our code. So we'll step into the shoes of the Tailwind Traders technical team and start to take advantage of some of the capabilities in Azure and GitHub, as well as start to bridge the gap and build a closer working relationship with our security engineers. Finally, we'll leave you with a pointer to a blog post detailing these capabilities and what you can do to start shifting your security process left and embrace DevSecOps workflows. Let's start by examining some of the security challenges facing us. DevOps has done wondrous things for us. We deliver faster than ever before. This has led to challenges in the quality and resiliency of our code. Over time, we've improved our development process and testing practices to consistently produce quality code. We focus on improving the relationship between those building software and those running software. But we've been missing part of the story. We're missing our security engineers. In many cases, security engineers aren't involved until code's either about to be delivered or is already running in production. We see these reflected in the statistics, with 62% of enterprises not having security integrated at the development phase, and over half, almost 60% of enterprises reporting that there are communication challenges between their development and security teams. These and other important findings are reflected in long remediation times. Fixing security when the problem surfaces in production is the most expensive in time and cost. We have some DevSecOps best practices that can be distilled down into 3 pillars: shift left, enhance observability, and extend a shared responsibility. When we first embraced DevOps practices, we followed a similar path with operational concerns. Shift left means that we move as much of our process earlier in the development cycle. If we were inspecting our firewall configurations in production, we would define those as requirements in code, for example, as Azure policy, and test compliance earlier in our development and testing flow. The earlier that we can find misconfigurations or vulnerabilities, the cheaper and easier it is to fix. Back to my firewall example. If I built my service expecting a particular port and protocol to be available, I may have to make significant changes in multiple places if that was disallowed in production. At best, we may have to change the configurations applied at deployment time, all adding up to delays and possible outages. We want to enhance our observability. We want to make security metrics and logs available to our development, our operations, and our security teams. By making this information available to our technical teams, it makes coordination, remediation, and even better, planning and engineering to minimize and reduce the impact of our security and compliance problems and goals. Finally, DevSecOps doesn't work unless we have a shared responsibility for security. Shifting left brings security considerations closer to the teams delivering features, but unless shared responsibility for the objectives of the security team, they have limited incentives to respond to the findings of those tools. Conversely, the most secure computer is one that's not turned on, has no data or software. Security teams need to share some of the responsibility for the delivery of features. They can't be the roadblock that everyone hits. They have to be there to help deliver safely and securely. So, what does Microsoft offer to help with these challenges? Between GitHub and Azure, we have a suite of tools and services to help. One thing that we'll find is that as teams build shared responsibility, there tends to be a shared set of tooling as well, whether it's the same tool set or integration between tools. We'll dive deeper into some of these, including a demo of how they come together in an existing project. from shifting left with GitHub to understanding the runtime behavior of our apps and infrastructure with Azure Monitor, to policy as code with Azure Policy, secret management with Azure Key Vault, Azure Security Center, which is our home for security, information, and status. Azure and GitHub provide building blocks to develop our DevSecOps practices. Now, everyone's talking about shifting left these days. In fact, I've already mentioned it several times. But what does that mean in a security context? By using tools from GitHub, we can build an awareness of understanding of vulnerabilities in our application's dependencies, as well as get automated pull requests to bump those dependencies to a patched version with Dependabot. GitHub secret scanning protects our repositories by inspecting every change set that's pushed to the repository. And CodeQL analysis can evaluate our application's logic, looking for insecure patterns in code on every change to a branch or every pull request, helping us to build this degree of confidence in the security posture of our code. Now, Azure Security Center, right, that offers us this view into the security posture of our Azure world and tools to help improve that. Azure Security Center provides us a security score and specific actionable things that we can do to improve it. From quick fixes directly in Security Center to instructions and deep links to problematic items. Security Center gives you the tools to actively improve your workload's security. And with that, I'm happy to introduce Lavanya Kasarabada, who has an exciting announcement for us.
Thanks, Stephen. Hello, everyone. I'm Lavanya Kasarabada, a Senior Program Manager on the Azure Security team, and I'm excited to announce the public preview of GitHub integration with Azure Security Center. Two of the pillars of DevSecOps practice, observability, and shared responsibility encourage a more holistic view of what happens in our environments. At last year's Ignite, we discussed ways to add additional checks to secure Docker images created as part of our continuous integration or pull request workflows. Now, this helps developers scan for common vulnerabilities in their Docker images before pushing to a container registry or deploying to a containerized web app or a Kubernetes cluster. Now we're taking our first steps towards building that shared tooling and experience by extending the reporting from container scans into Azure Security Center, providing security teams better insight and understanding as to the source of vulnerable container images and the workflows and repositories they came from. Azure Security Center can provide recommendations on remediation for the affected images, giving the security team a way to provide actionable feedback to the development team. This feature is now in public preview, and you can read it more at our AKS DevSecOps Build 21 blog. Now, before we go to that, let's see some of these DevSecOps ideas in practice, as well as what this new capability from Azure Security Center looks like.
So thank you, Lavanya. All right, it is time to get into some code. Or, let's reset the stage a little bit here. I'm going to reintroduce myself. So I'm Stephen. I'm a developer on the Tailwind Traders team, and I and my team build line of business apps for some of our public-facing projects. For me, security has always been handled by our security team, but I'm starting to get pressure from our leadership to address security concerns earlier. It's been tough to get our security folks involved, though, since they aren't part of our day-to-day operations.
Hi, I'm Lavanya, and I'm on the security team at Tailwind Traders. I'm responsible for ensuring the security and compliance of our publicly facing properties. It's so hard to get our developers to care about security. They just want to ship code and can't seem to wait for a security review. I wish we had a better way to work together.
As I mentioned, we work for Tailwind Traders, and the application that we'll be looking at is our e-commerce site, which consists of several container-based microservices layers, supporting our web front end. Since it's our organization's primary public-facing endpoint and processes transactions, security is a growing concern. So let's make that story better for our Tailwind team. I'm currently within our Tailwind Traders web project here right in GitHub. And now there's two ways that I can quickly and easily turn on security features that are baked right into GitHub itself. The first way is to navigate to the settings for this repository. Now, from there, I can drill down into security and analysis. From here, we can begin to turn on three specific security features. The first is dependency graph. That'll help us better understand our dependencies for our project. Now, for the purpose of this demo, and this is a public project, by default, dependency graph is always enabled for public repositories. If this were a private project, I'd go ahead and hit enable. The next thing I want to do is turn on Dependabot alerts. This will allow our Tailwind Traders developers to receive alerts of new vulnerabilities that affect our dependencies for our application. The third setting that I want to enable is Dependabot security updates. This will not only help us identify vulnerabilities within our dependencies, but it'll submit a PR to bump the version to a patched version. From there, we can review and merge that pull request or decline that pull request accordingly. Now, continuing on our security enabling journey, I'm going to head back over to the security tab again from within the project. As you can see, I'm giving a security overview, which builds on the features that we just turned on in settings. The first thing I can do is learn about our existing security policy, and I can refine it as needed. So that's in accordance with our Azure policy that we need for our Tailwind Traders Enterprise and aligned with what Lavanya and the rest of the security team want us to have. We can even have guidance for how we can report security issues directly to Lavanya's team. Now, moving forward in the list, we can make note of the security advisories. This will allow us to discuss a fix and publish information about security vulnerabilities that have already been identified in our repository's code. In fact, we can click New Draft and define affected products, the affected versions, and we can mark the severity level, the CVE identifier, and we can even give a description of the problem in Markdown. I love writing in Markdown. Now, the next thing that we can do is look at the Dependabot alerts. We're given this information as a direct and immediate result of the feature that we enabled in settings. And they range in severity level from low severity all the way up to high severity. I can drill down on any of these. Let's take a look at the SSRI high severity issue, for example. I clearly can see that we've got a CVE that's been identified, and I'm given the vulnerable versions as well as the patch versions needed to resolve this high severity issue. Now, let's talk about code scanning. Code scanning is a very powerful and easy thing to configure. When we click Set up more code scanning tools, you'll find that there's quite a few tools that we can pick from. These tools utilize security best practices and will provide us security analysis for a broad range of programming languages. I've already configured the CodeQL analysis, which is provided right from GitHub for our Tailwind Traders project. And I ran that workflow right before this session. So you can see the results of our CodeQL scan here. And what's really neat about this is at Tailwind Traders, we use a combination of .NET 5 and React. And CodeQL was able to successfully analyze both the C# and the JavaScript code quickly and easily. This is great news. Finally, I want to highlight the immediacy of turning on some of these features. We just enabled Dependabot alerts a moment ago, and I can already see I've got 3 PRs open. Now, once the vulnerability has been noticed and a patch version has been identified, a pull request will be opened automatically by GitHub, thanks to the settings that we've turned on. We can drill down into one of these PRs and see not only do we have a Dependabot comment on this pull request, but we also have that our workflow checks have completed, successfully showing us that it's safe to merge if we want to. Now that Tailwind Traders has taken advantage of some of these security features from within GitHub, I want to learn a little bit more from Lavanya, who's going to walk me through Azure Security Center and has a few more suggestions on how we can ensure that security is going to be central to our project's workflow.
Thank you, Stephen. All right. I'm currently in the Azure portal in the Azure Security Center. From here, I'm going to navigate to something called Azure Defender under Cloud Security over here on the left. Now, as a security professional, this Azure Defender page gives me a wealth of information about everything that is currently going on in Tailwind Traders Azure subscription. One of the areas I really care about is our container images in Azure Container Registry. Since Tailwind traders went all in on cloud native, we are pushing a lot of Docker container images into our Azure container registries. And I'm really concerned about the quality of these images from a security perspective. I'm going to click on container image scanning. And once I do, I can see some suggestions right from Azure Security Center. Number one, I can see I have unhealthy registries in our organization subscription. These unhealthy registries have a severity level of high. 2 vulnerabilities have been detected, and registries with the most vulnerabilities are ones we use for our Tailwind traders production environment. Now, if I want to see the affected resources under affected, I could drop this down and select our Tailwind traders registry. We have our Tailwind traders web repository, which has 4 images scanned so far. If we drill down even further, we can see the digest information, the scan report time, the tags for each image, as well as the media type. Now, one of the things that I want to highlight that's very new to Azure Defender is this column right here for the CI/CD scan findings. You can see that all images are currently unscanned, which means that we don't have container scanning enabled in our CI/CD workflow in GitHub. We have 2 GitHub Actions we can easily add to our workflow to help us gain insight into the health of our container images even further, and to have greater observability into where our images are coming from, which workflow is pushing them, which commit, and which team is responsible. The first action is the container scan action available here, which uses Trivy to detect vulnerabilities in images, and Dockle to detect Center for Internet Security, CIS, best practice violations. The second action is the publish results action available here. Stephen, do you think you could help us out and add these actions to our GitHub workflow?
Sure, Lavanya. Now, I'm currently in Visual Studio Code within the Tailwind Traders project, and I'm looking at one of our workflows. I've made a few changes here using the actions that you recommended. And you can see I've got a build stage here that will now do more than just build. We start by checking out our code. Then we log into Docker. We build our image, scan our image, and then push our image. Now, previously, we would just simply build and push our container to the registry, and our workflow would end there. Instead, by adding the 2 additional steps that you recommended, now we're following our build step with the scan step. As you mentioned, this will scan our image for vulnerabilities and best practice violations. And the second step that I added after push will publish those results over to Azure Security Center for you to review. Now, I just pushed these changes, and the scan's running as we speak. Now, a key feature I've taken advantage of to get this set up is the ability to use secrets within our Azure GitHub Actions workflows. Now, secrets allow me to securely and safely pass sensitive information to our workflows. If we head back over to the settings part of our project and we scroll down, we can see there's an area for secrets. Now, you'll notice I've got quite a few secrets in this project, and we're able to store all of those in an encrypted manner where even if I wanted to go look at them now and see what the value contained, we'd be unable to do so. We could keep those secrets in Azure Key Vault and use a GitHub action to access those secrets to give even greater control of sensitive information. Now, this native functionality gives us a tremendous amount of control over our secret environment variables. Let's look at the results of our completed workflow. And you can see 2 jobs ran, 1 was successful and 1 has an error. The first job is building scan, and the second is not a job, but it's the results from the container scan report. So we can see that we've scanned the image that got pushed over into Azure. We can see the summary, which includes 10 high vulnerabilities, 2 critical vulnerabilities, and on top of that, we have 3 CIS best practices violations that are info level worthy and 1 that's warn level. Now, luckily, we have 0 that are fatal. And we can see by the vulnerabilities, we can see them by CVE, and we can see the specific best practices that were violated and that were detected. We can even drill down into the job itself and see each step that was run and each step that aligns with the file that we just reviewed in Visual Studio Code. Now that this is pushed over into Azure Container Registry with our container scan results, Lavanya, can you go ahead and refresh your information in Azure Security Center and see if you're seeing that updated CI report now?
Absolutely, Stephen. From within the Azure Security Center here, I'll navigate back over to a container image scanning area, and you can see under affected resources. I now have 6 number of scanned images. Previously, I had 4. We're going to drill down into this. And yep, here is the latest image that you just pushed. I can see it looks like the related CI/CD scan is found. Drilling further down under CI/CD scan findings, I can hover over the information point and see deep links back over to GitHub, where now I know the specific workflow that fired off this particular image into the Azure Container Registry. I can also see the same vulnerabilities you saw within your GitHub Actions report from Trivi and Dockle. This is fantastic. We are one step closer to building that bridge towards true DevSecOps.
So Lavanya, how did you get those instructions to onboard my CI/CD scan results into Azure Security Center?
Oh, it's super simple, Steve. You can navigate to the settings page on Azure Security Center after selecting your subscription. You will now see the new CI/CD vulnerability scanning configuration section. Go ahead, click on that. After you click on that configuration button, you can now select the application insights workspace pertaining to the region that you want. You can then add the connection string and the authentication token into your GitHub workflow. That way, once you enable CI/CD scanning and run your workflow, the CI/CD scan results are then pushed to the application insights workspace for the backend service to send it to Azure Security Center. So you can see, Stephen, that we now have a holistic end-to-end experience to bring security assessments from shift left to your runtime resources. We do plan to add support for Azure DevOps in the coming weeks, and we also plan to add more security capabilities like credential scanning and malware scanning.
Wonderful. So now that we've seen how we can start our DevSecOps journey with GitHub and Azure, check out this blog post, which has how we can get started leveraging that preview of integrating our CI/CD scan results into Azure Security Center, as well as other DevSecOps practices. Now, as you've mentioned, that Azure Security Center integration is in public preview, so we want your feedback, right, Lavanya?
Absolutely. The blog post linked contains detailed instructions for getting started and an email address to reach out to our team for support. We'd love to hear your feedback and how this integration between Azure Security Center and GitHub can support you.
We also have a great white paper to help you focus your DevOps journey at aka.ms/DevSecOps paper. This white paper dives deep into 6 things that you can do to improve your environment with actionable guidance and industry examples to help bring security into your DevOps journey. It starts by building a security-first culture. As you saw in our session, there's often a tension and a separation of responsibilities that can be difficult to address. Building security first and making that a responsibility of every step in our process helps create that security-first culture. The second tip is all about the shift left. Time and again, we see that the earlier in the development process that we can address problems, whether it's security, quality, whatever, the cheaper and more effective it can be. The earlier we align on our objectives and start to validate them, that we're going to reach them, the more likely that DevOps and DevSecOps value will be realized by our organizations. Third, we want to be intentional about what we monitor. Back in the bad old days, we'd monitor everything around the OS and application stack trying to infer behavior. We'd see alerts for disk queue length and wonder, is something wrong? Because we didn't have specific objectives for our monitoring outside of let me know before something bad happens and before our users know, it became really easy to let alerts and logging just become noise. When we put a specific focus around the things that we monitor and alert on, alerts become much more actionable and there's context as to why they're important. Fourth, and this is one of my favorites, everything is code. By defining our build process, our environment configuration, and policy as code, we provide ways to monitor change and build understanding of our environments and how they evolve. Controls and expectations of our environment are surfaced earlier and to a wider audience, helping reduce surprises as we move forward to production. The fifth tip is to use automation to help enforce and validate compliance. With the compliance landscape changing as quickly as our application environments evolve, automation can help us keep compliant and quickly identify those areas that fall from compliance. Finally, the last tip is around our software supply chain, and this is something that we highlighted in our demo here today. Building an understanding of the components that we bring into our application environment, whether they're libraries and frameworks, application platforms, or base container images, we're responsible for every bit that we push into production. And of course, we're responsible for making our code secure. But we also need to ensure that the dependencies that we use are current and don't have known vulnerabilities that can affect our use case. But don't take my word for this. Go grab that white paper, dig into the specifics it offers to help you integrate security from aka.ms/DevSecOps paper. Now, thank you for your time and attention today, and let's get out there and start securing our code.